Good morning. In our physics lab 1, for today we'll do experiment number 8, which is the thermal expansion of solids. So in this experiment, the objective of this experiment is to find the linear coefficient of expansion, the linear expansion coefficient of two different metals, which is the steel for a steel tube and for a brass tube. First, we will start using the steel tube with an initial length for the steel tube of 600 millimeters. So as you can see, we have the tube starting from 0 and the screw at the end of the tube at 600 millimeters. In order to do the experiment or to complete this experiment, we are in need to use a dial gauge with a screw here in order to measure the difference of lengths, the variation of lengths of the tube. So we can, using the dial gauge, we can measure the expansion of the steel tube and for the brass tube. We are in need of a blower and heater. So this heater will heat the water, will increase the temperature of water, and then will blow them by the rubber tube into the steel tube and go back to the aquarium. First, we will start by the initial temperature of water, and we will measure the variation or the variation of the length of the steel tube at each 5 degree of each increment of 5 degree. So let's say we start by 20 degree temperature of water, initial temperature of water. At 20 degree, we adjust the dial gauge at 0, and then we will measure at 25, 30, 35, and so on, until we reach the maximum temperature, which is 70. So we will do an increment of 5 degree, and we have to complete this table. We have to complete this table for the steel tube with initial length Li 600 millimeter. We have the temperature of water. We start by the initial temperature of water. Delta T is the variation between T final and T initial. We will measure delta L using the dial gauge. Delta L, which is 10 to power minus 2 millimeter. And then we can calculate alpha, the linear expansion of solids. Here we say linear expansion because we are only measuring or taking into consideration the expansion of the tube in the x-axis. So in fact, the tube will increase or the expansion will occur at in the 3 dimension in y-z axis, as well as on the x-axis, but only the x-axis variation will be measured. So to start the experiment, we turn on the blower, and we have to look into the initial temperature of water. In our case, it is 25.45. I have to adjust the dial gauge at 0 and then start the experiment. So now لكن 24.5. We must take or read the expansion at 29.5. Now it is at 27.4. $29.5. It is at 2.5. So delta L is 2.5 times 10 to minus 2 millimeter. خليني بس اخذ شي 3 4 ونرجع نوقف.
لا شو رايك؟
لانه هي رح تطفي هلا هي رح تطفي. So next at 29.5 and then at 34.5. شو كان رأيك؟ شو كان بدك تقول لي؟ At 34.5, 6 or 5.8. 5.8 times 10 to minus 2 millimeter. And the next one will be at 39.5. So after completing the measurement for the steel tube, we have to change the steel tube and replace the steel tube by the brass tube. It's 39.5, 9.5. So after completing the measurement for the steel tube, we have to replace the steel tube by the brass tube at for initial length of Li 400 millimeter. And then we need to repeat the experiment using the brass tube as well, but with the initial length of 600 millimeter. Now we have replaced the steel tube by the brass tube, and as you can see, we adjust or we put the screw at 400 millimeter. So all the expansions that will occur at far away from the screw will not be taken into consideration. Only the expansion from this side will be measured by the dial gauge. Now, as well, we have to adjust the dial gauge to 0. And by repeating the same steps, we turn on. Okay, it's at 0 now. We turn on the blower and again we have to adjust the needle at 0 by seeing the initial temperature of water, and then we read the value at each 5 degree at each increment of 5 degree of temperature. And after filling the table for the brass tube at 400 millimeter as initial length, we move the screw to the new position, which is 600 millimeter, and we repeat again the experiment by taking or by reading the value of delta L, or the expansion, at each increasing of 5 degree or 5 degree steps of temperature. That's everything for this experiment. Now we filled we have filled the tables, the 3 tables for Li 400 millimeter for brass tube with initial length of 600 millimeter, and the steel tube with initial length of 600 millimeter. Now we have to do the calculation of alpha. The calculation of alpha will be done using the equation L final minus L initial is equal to L initial times alpha times T final minus T initial. Another way, it is delta L, so the difference in lengths, equal L initial times alpha delta T. So in this experiment, we did two different metals, the brass and the steel. And we will see that for the linear expansion coefficient of the steel is different from the one of the brass tube. However, for the brass tube, we did two initial lengths Li 400 millimeter and 600 millimeter. We will see that the expansion coefficient for the brass tube will remain the same, whatever the initial length is. This is logic, since the linear expansion coefficient, it's a physical characteristic of the metal. So it does not depend on the geometrical shape or the geometrical parameters of the metal we are using. So for a brass tube of 400 or 600 millimeter as initial lengths, we will have almost the same linear expansion coefficient. However, it will be different from the one for the steel tube. That's everything for this experiment. Of course, we have to answer the questions existing at the end of the experiment. We have to draw, I don't know, yes. No, we have to calculate the average. Yes, we have to draw two graphs of delta L versus delta T for the brass tube with initial lengths 400 and 600 millimeter. That's everything, and see you in the next experiment.